Hello again, everyone. This is me, Asom Hilmi. I'm a success partner with OBA Energy, and I will be your moderator in today's webinar titled Thermal EOR Modeling by CMG. Today's webinar marks the webinar number 70. You can find all these free webinars on our YouTube channel on YouTube. This is a typical presentation for our upcoming services plan and for our quarter courses plan for the upcoming 2 or 3 months. So you can see here on my dashboard in OBA Energy in numbers and different teams from different countries regarding our representation on the social media and every service that we provide, from internships, courses, live courses, mentorship programs, and you can see our representation on the map on the right down side of my screen. The upcoming live course is titled Thermal EOR Modeling by CMG, which will start on the 19th of August. You can get your discount by being an early bird for this course and getting like $90 discount. So this is our 9th wave courses in OBA Energy through the months from August to October. We will start by the thermal EOR modeling by CMG, like I have just mentioned. That will start in the 19th of August and end by the 24th of August. For the second course, we have a very interesting course titled Well Integrity Management System that will start on the 2nd of September and end by the 7th of September. The third course is Applied Reservoir Geomechanics. This is very important course for the nowadays activities done by the CCUS, carbon capture, utilization, and storage. So the last course for this wave is a stack pipe prevention that will start by 30 of September and then by the 5th of October. You can see that we have a break day inside these 1 week courses that is highlighted in light black, which are actually Tuesdays. So we have also early bird for each of these courses. You can enjoy your discount. You can see the prices on the right side of my screen. Also, we have a package discount. This is nearly 50% discount on the prices of all these courses. You can save up to 525 bucks instead of $1,050. For applying and registering in any of these courses, for all of them, you can scan this QR code. I will give you just a few seconds to do this, and I will also share the links for registration in the chat area right now. Yes, done. All right, this is our history of live courses that are available now as recording. You can see that we have here like 5 different bundles: reservoir engineering, production technology, rig and rigless operation, open and cased hole logging, and also miscellaneous courses like petroleum economics and different very interesting courses. You can find also the title of the course along with the price of this course beside it. This is also how the bundles are on our website. This is the QR code for you to scan to apply for any of these live recorded live courses. As I mentioned, that we have a mentorship program. This is a special training, one-to-one training that you design with your instructor. I really encourage you to visit our website, find all our interesting services on this website. another screenshot from the website. This is some lovely pictures from our internship programs that we provide to different group of students from Lebanon and different countries. You can just be an ambassador by joining us in any of our services, being internship, live course, recorded course, mentorship program, or any other service that we provide. By being an ambassador with OB Energy, you can enjoy very interesting discounts on your on our learning services. Just a few rules before heading to our presentation today of main webinar. I have muted all the microphones so that you can all get a clear message from our instructor, and also don't show your camera with us. I will close it. So sorry for this. If you have any question during the webinar, put your question in the chat box. It's better to keep it to the end of the webinar so that we have all the questions by the end at one time. If you are, please keep your camera closed. If you joined us using like Galaxy or iPhone, I really encourage you to rename yourself, as we will be sending the certificates of attendance in 1 week from today's webinar. This is all from my side. Thanks, and over to Mr. George, our instructor for today's webinar, to start our webinar. Thanks.
Thank you very much, Sam. Hello, everybody. First of all, I'd like just to introduce myself. I am a reservoir engineer or senior reservoir engineer. I have more than 10 years experience in heavy oil and thermal steam injection. So I believe I can present for you a good issue about CMG simulation for thermal. And I believe by the end of this webinar, we will find a simple way to create like a pattern of steam injection, and quickly to know what the simulation CMG, what is the advantage of CMG, because it's a good software and interesting software also. I don't know you see my screen or not, but I start sharing. Okay, I try to make. Okay, you see my screen, everybody? Okay. Today will be a quickly, maybe in the course next after 2 weeks, it will be step by step. So I hope if there are a quickly steps and need more details, I can submit for you the details, but by the end of webinar, because we have limited time to finish. CMG is a company called the Computer Modeling Group, and starting 1978 as a research foundation, then create by 1980 create a black oil simulator. Then create a GEM, is a simulator for composition and uncomposition simulation. After that, create a star and thermal simulator. So by the 1983, they create all simulator for all the different application for simulation, black oil, compositional, and also thermal. And today we will go to thermal simulator and thermal case. After that, create an application to make an equation of state, which is called webinar. After that, create like a pre-processor to build the model. It's called Builder. Then create a post-processing to show the result. With time, so we speak about 40 years. With time, create other applications related to asset modeling, and also assisted history match and optimization model. and well-bore model, and this is very beneficial in thermal and other application, unconventional reservoir, to make a well-bore modeling. Currently, CMG, let me zoom, CMG company, 100% of the top 20 Canadian heavy oil producer using CMG. So once you have this application, once you can able to use this application, it will be put a great experience to work and to be facilitate and model like a big heavy oil producer worldwide. CMG have different applications and a market leader for all EOR method and advanced recovery process, like unconventional method, pipe and shale oil and gas, compositional, CO2 injection, gas injection, nitrogen injection, RABEX vapor extraction injection, which used for heavy oil as a solvent. Also thermal application for SAGD, steam assisted gravity drainage, and cyclic steam stimulation, steam injection, air injection, hyper process, and chemical injection, alkaline surfactant polymer, foams, gel, loose aligned, and also geochemistry. Sorry. Geochemistry application and function. Now CMG cover 90% for all worldwide countries, for all the countries, Gulf, Arab Gulf, and Russia, and also Europe, of course, Canada and America. So this is a good software and good application to be used and to be learned and to be know everybody, especially if you will work in EOR and especially thermal and heavy oil application. Now, let's go to CU. I will share again my screen, my desktop. Okay, share, and then stop sharing. I don't know why. It's okay. Share again. Share. Like to share my screen. And I share my screen. Okay. Still why 1 minute to stop sharing because I have problem in share, and then I can go to my screen here my screen, share. Okay, stop share. Stop sharing, share. Okay. Okay, let me check the application. Okay, let me check. Let me show all windows. No, 1 minute. Okay, share and show. Okay, so you see my screen now. Okay. In my screen, you can find this is a desktop, and after install CMG, this is a launcher of CMG. If I open it, you will find the all application related to CMG. Like I mentioned, Builder is pre-processing, and the result is a post-processing. And GEM is a simulator for compositional. IMAX is a simulator for black oil. STARS is simulator for thermal. When Prob is related to equation of state, CMOST is assisted history match and optimization models, and the other modules related to run in cloud and something like that. Now, let's open Builder and try to build the model, and I will show to you it is an easy way to build any models. So once I open the builder, there are like any software, the first part is create new. Then the builder will ask us which model will simulator will be used, compositional or black oil or stars thermal. So I will select, for example, black oil now, just to go step by step, and then working unit, start unit, SI unit, or field unit, or lab model, or something. I will SI unit, and then simulation start date, and I will speak 2000 Jan day number 1. This is just quickly, just to know how to create. And then also he asked about the porosity, single porosity or dual porosity or dual permeability or other issue. Then he confirmed simulator will be IMAX, units, and the starting date. Any other, it's okay. Then tell okay. From this screen, you will find the organized way, a workflow to build your model. Even model tree view like that, or even from above. After edit and view and input out control, you will find the same word: reservoir, component, fluid, and rock fluid with relative abilities and other capillary pressure, initial condition to initial urodynamic model, and the numerical application. Here also numerical, and optional module related to geomechanics and tracer, because this is very important if you go for advanced for EOR to test and simulate or make a study for EOR. Then data related to well and other tools. We will investigate these tools while our work. Then option related to window, like to be horizontal, to be vertical, and something like that, or go from window to window, like here to here, to go to the other window. To start your reservoir, you must be create a grids or enter your static model, because CMG not a static module like Petrel or Petrel static or decision space, but it can be used the exported one from this model and start your model. In other way, you can build your model here also using similar way, but not complex like Petrel. Okay, so let's go to see the option to create your grid, your models. Okay, there are 3 methods to create your grid. First, if you go reservoir, like I mentioned here, and simple, we will create a Cartesian and make a grid type Cartesian. There are 3 types of grids to be simple: Cartesian, orthogonal, corner point, non-orthogonal, radial, and quick pattern. Now I will select Cartesian, and I will put 3 blocks in I direction, 3 blocks in J direction, 3 blocks in K direction. Then I tell you one question. Please write your question, and by the end of session, I can answer your question. So 3 blocks multiplied by the thickness of this block. So it will be 3 blocks multiplied by, for example, 110 meter, and 3 blocks also multiplied by 10 meter for in a J. For K depths, I will manage it once I build my model, my grid. So I will click OK. So I have like grid like that. Okay, it's 3 by 3. Then I will go to this tab, it's called Prob Mode, and try to fill a property of this grid. So he will ask me what is the grid top. Simple way, I will tell him layer 1, for example, 1000 meter subsea, and grid thickness, I will tell for layer 1 it will be 5 meter, layer 2 it will be 10 meter, and layer 3 it will be 7 meter. And then okay, and then for porosity I will also make different 0.2, 0.10 and 0.3. For permeability I will tell permeability I will make a function for permeability, so I will click here okay. Then he informed me you change grid thickness, grid top and the porosity. I tell him okay. So if it's easy to go here to select your view aerial or IGK 2D or JK 2D, or you select 3D view, and from here it's easy to make a rotation for this, and from here it's easy to make, sorry, here it's easy to make a zoom and come back. So from tools we create a formula and we tell him new and add independent variables and select like a porosity. Okay. And this formula is related to permeability. And we'll create a function between permeability and the porosity. So insert selected formula. So which meaning permeability equal porosity, for example, multiply by 0.10% from porosity. After that, we tell apply. Sorry. Okay, and put change the wrong to right, correct, and then okay, click okay. Then specify property again, and in permeability, we go to layer 1 and select formula, and from formula select here and select this formula. Okay, so the formula will apply in the layer 1. I can go to make a copy and apply paste for the second layers. So I have applied the formula for all layers. Then for permeability J, it's equal permeability I. So I can, for wall grid, I can, for wall grid here, I can go and tell not formula, but equal. So will give me a screen and tell me I will not constant value, but equal I, yes, equal I, and tell me him okay. For permeability in direction K, it's me assuming 0.10% from permeability of I. So I will give like here, not formula, but equal, and tell him equal, multiply by 0.10, 10%, and okay. And then click OK. I changed now permeability I, permeability G, permeability K. Yes. If I need to navigate each property from here, permeability I, permeability G, and also permeability K, you will find here the scale. And if right click on a scale, set scale color, and you will find the range minimum value is this value and the maximum value is this value for permeability K. Apply. Okay. If you need to change the range, okay, you can come here, set color, and try to change the range from here, for example, 0.2, apply. So the maximum will be 0.2, not 0.3, cancel. Okay, so he make a filter. Anyway, if I go to need to select the original scale, I can go to color scale, set color scale, and select the all grid and then apply. Okay. If I need to show the statistics inside this box, so I can go to tools and then from here I can go to grid property statistics. It will give me too many number of blocks, 27, and number of active blocks, and total bore volume, and also statistics for permeability, like you show here, the minimum value and the maximum value, and also average value and the weighted average value and something like that, and also per each layer, what is the percentage inside the graph. So it's easy way if I change K permeability, it's easy also to go for the other parameter and check. Okay. Just for the easy way, like I mentioned to you, every time you will find if you are finish this step, it will be like a correct with green. If still missing parameter, like here, it will give us warning. So it's easy for any engineer to follow up step by step to build their model. But now I just need the step to create a grid to start my work. The simple way, I just create a simple grid like that. If I need to know what is the problem, I right click and click validate. He told me a validate component is required. We need to fill this. I max require at least one table. So give a guideline to solve your problem, and just easy in a language and easy steps to finish. Again, if you go here, there are one parameter is needed to finish. Maybe not the model can be run, but it's mandatory for reservoir engineering. So he put yellow rectangle, triangle like that, and should be change the compressibility, something like that. So this is the first step. There are one question. Voice is slow. Okay, you need to speak in slowly. Okay, I try to speak in a slowly. Also, okay, I hope my voice will be now. Okay. If a problem in my voice, please inform me in chat to increase my voice. So this is the first method to create your grid. I will make another, I will show for you another method. If you have well trajectory and well logs and well tops with normal data, basic data to build any model, and need to build your model in Builder. So I will create a new one. So I will go to close this. No. And new. Whatever I have, I will create max, under unit, whatever the date. This is not an issue now. And then start to create the model. So the first step, I will go to here for a wells. I have a well trajectory, 3 items. I have well trajectory, well wells, and well tops. I will use well trajectory first. So create from well, create import well from trajectory data. And I know is in a table format. So I will select table format and search for a table format here. Okay, let me go to okay. So this is the table of all wells. If I open, okay, you will find units is meter. Okay, the same which I built. The name of well ID, and date, and X and Y, TVD sub C, and measure depths. So normal table, and then I will open. Next, I will put him like that. If I need to deselect one of wells, I will deselect. And then next, if I need to change the name trajectory, I can change from here like this. I can change original name, match the trajectory, something like that. And I will make a finish. So I load all trajectory. If I make a zoom, okay, I zoom to the well here. It's a vertical well, but you will find the name of wells in the bottom. Like any software, if I need to change the properties of this screen, I will right click properties. This is the well trajectory. I will search for a well trajectory here. So I will go to here. Then I will tell display on the top. That's it. Simple way. Change the location of label to display on the top. After that, I need to load to Builder the top formation. So I will go to well and no new well event. No, I will go to well trajectory, and then from well trajectory there are like import well log and import formation tops file. I will go to my folder again. I will go to geomodeling. Okay, required data tops. I will open just to check. Okay, so the name of well and also top and measure top like that. Simple, simple, not bad, simple table just to use as a data entry for our mod. Okay, he asked me, the builder asked you enter top, but there is no bottom. And you need to enter. No, I don't need it now, so I will. Okay. Did you see it? It's like red issue. It's represent two tops of each well. Then after that, I will, if I need to change also the shape, anything related to the tops, so it's easy. I can go to properties and well trajectory tops. And I can change the color. Let's change it to orange. Let me select other dark green, apply tool, change it to dark green. If I need to unshow, I can don't show it. I need to show, apply all. Okay. If I need to increase the cycle properties, not me. Here, disk size, I can increase disk size, apply all. It's easy, can increase, okay. Admin, and here, more clear. Okay. So I input the well trajectory and input the disk of well top. Then I need to create like a map to make a contour mapping. Then after that, I can easy to create any grid issue or something like that. So I will create a map file, and this is the map file, whatever the name. And from here, I will go to import the logs to with the well tops. So at this point, it can easy to create sorry, from here, I will use the well trajectory to create my map. So import tops from trajectory. Yes, using the tops. So well X and Y, and also put value of top here. Then fault, I can put fault. In this case, I don't for method. Then I need to distribute the spacing the tops between the shape of round between the tops. So I use the statistical method to create this distribution. So there are different ways to create and simulation, geostatistical simulation to create these topes. For example, I will select here, and the change not in one direction, in two directions. So I will tell you by one direction. So then I will check the variogram between tops and the variance between tops and simulated from software, from builder and the actual. So the dots, this one and this one, is the actual variance histogram. And this is the data from a model. After that, I will try to move this point. Sorry, I cannot. Okay. Move this point to try to match between the simulated data and the variance, whatever from the simulation. That's the actual variance between the actual tops. I can show that. And once I have the match between simulated data and the actual variance variogram, I can be used to build my model, or to build the contour map as the first step of this method. So it will take time. So I will show you to webinar. I will go to load the final one. But anyway, there are here also variogram types. There are different variogram types. So I will change it like Gaussian, and then okay, and then check variogram again. There are change in a shape, try to rematch, and so on. Anyway, I will not complete. Then in mesh, I will select how many mesh to be used in this step. If it's okay, I will tell okay by the end. But let's loading the good one. So open map file. It's saved by CMG mesh format. I know that, so I will use it and go to the folder. Here. Okay. And then top map.mesh. And then okay. If I change the view to 2D, I have a contouring map using the top and trajectory. If I need to change the thickness of contour or color or something like that, easy. On this step, I will right click properties and I go to grid. I go to map. So in maps, there are like a contour map. It's easy to go to here and change the color, for example, red, increase the weight, white, and apply all. It's easy to change it. So I have like contouring map using trajectory and tops. And now I will create like a grid to create a box model, whatever, create a shape of reservoir to be used for a model. So I will go to reservoir and create a grid, and using orthogonal, in this case, an orthogonal corner point. Then from my, because I go to do that before, I will tell you what is how many blocks. Let me check. Okay, is 81, 40, and 20 layer, and 81 in I, and J is 40. Then I will write 81 blocks multiplied by 180 meter, 0.5, and then 40 multiply 180.5. Then I will click OK. I create the mesh grid, but unfortunately its position is not matched with the map. So I will go here again and edit grid, and there are reservoir, edit grid, and modify position. I will find the Y offset here is 5,300. So I will change it, easy to change it to 0 and click apply. Now it's okay. Okay, now so I create a grid, I create a simple contour map using trajectory and the tops. And now I'd like to make a thickness for each layer, create tops for each layer, identify tops for each layer, and also thickness and all the other properties. So from here, I go to Prob Mode, and this is a Prob Mode. It's called Prob Mode, and then specify property for these grids. Until grid top, I will go to layer 1 and click here. Do you remember we already create a map? It's called mesh map with geostatistical distribution between tops. So we'll use this map for grid tops. So we'll go to geological map and contour map. Yes, value in file. We'll create, go to file, top map, until open. Okay. Yes, we don't multiply by anything, or we don't subscribe by anything. So okay. So this is the top map. For a thickness, we have other map with thickness grid. So we will use it, contour map, and then it's called thickness map dot mesh also. There are other extensions, there are different extensions if created by other software. Okay, then okay. And then for a thickness, we will multiply by 0.05. To divide it, the net base thickness into layers. And then this is simple way, just simple way. If you have like a logs, we can distribute logs. This is to find the thickness and make a best for all layers. Now we have a grid and thickness. And if I click OK, you change grid and grid thickness and grid. Yes, OK. So in just 10 minutes, you create your grids. And if you go to 3D view, it's easy. I need to not show the contour map, so I click properties. For a map, contour, I will click here. Okay, it's easy. And then it's easy to make a zoom and define the each layers. Now I need to make a distribution for properties. Do you know how to distribute the tops? We will follow the same methodology, but using logs, not formation tops. We'll use logs to distribute porosity, to distribute permeability, to distribute anything. So we'll go for reservoir here. If I go here or I go here, so I will select here. Then I will go down. There are like a geostatistical. Can select here. Then I will create a new from here, name. It's empty, so I will create a new. And I call the porosity. Underscore simulation. Okay. Then I will tell him I need to distribute porosity. So I can click P. He will go directly to P. Porosity. Now I'd like to loading the logs which include porosity. So I will go tools, import the data from import logs or table of measure depths logs. Okay, and import logs. slash file or other. We have using normally using less file. So open file and less file, all wells here, Control A, open. It's easy to download. Now we'll click 1 minute. So now, okay, we're loading all logs, and then we will select wells. If we go, we can select well by well, or we can select all right here. Then click OK. Okay. Now we need to select what's the name of log to be used for this is a prosty. So we'll use the prosty log. This is a prosty define, and then we'll use per each layer will be used like average method, harmonic average, simple sum using different arithmetic. Then click or create a live function. Then okay. Now we have well x, y, and z layer. We have 20 layers per each well, and the value of prosty per each layer. After that, we should follow the same methodology like ops to make a distribution using statistical and geostatistical. This here is like a function, and here to see the variogram and check the match and something like that. For all properties, we make loading like that. I will show for you now. Cancel. Yes, I don't need to save, and I will show close these also. Do you want to know? And I will go to open the one what I have, the model distribution, and this after complete all distribution of all. He search for a mesh map location, so I will go to okay. Okay. Here, after load all the data, especially for grid, in this GeoModeler already also loading all component. I will do for that, but anyway, it correct, which meaning define every parameter, everything related to reservoir. If I select array properties, I can check define the grids correct, which means defined. Okay. And BVD and permeability also. Permeability J is equal permeability I. If I need to go to property specify, I can click this screen from here, or I can open from here. Okay. Prosty also, all of things, and rock compressibility. So he defined this is the data already defined for these grids. If I check 3D model, 3D shape, also here defines the 3D shape. Now I'd like to show the statistics per each property. So permeability, like we mentioned, even I go to scale, city scale, this is the range between 1.5 millidarcy up to 1,462 millidarcy. Okay. Or sure, I can make a filter by change the range. Sorry. I can make a filter by change the range. Or I can go tools and then here grid and the property statistics, and easy to find. This is the normal information about the grids, and then statistics for permeability, and tell us what is the minimum value, what is the maximum value, what is the average value, what is the weighted average value per block volume, and weighted average value per bore volume. Okay, So I have statistics and definition of the grid. In parallel also CMG, if you select Prob Mode and this is permeability, it's easy. If I go and click left button on my mouse, I easy to check block by block what is the permeability. This is 40 millidarcy. If I go to here, this is a higher permeability, 633 millidarcy, and so on. So I can check the model and make a like that. A second way to create your grid before you start the model. So the first way to go here and simple way create a grid, Cartesian or radial or something like that. The second way to, like we show now, to from tops, well trajectory here, well trajectory and well tops, and then define from the map, and then make a geostatistical. Somebody ask something. Not showing depths until unit in software. The unit not usually defined by the first of building the model. So if I go to here, I will close and create a new. You should define the unit before you start. So you should check what is the unit in logging, what is the unit in your data before you start to build your model. Okay, I think and I believe in Betrel also, before you build your model, should be define the unit, because there is no converter while in his build the model. Here also the same like Betrel. Okay, we'll go here model. Okay, now I'd like just okay, I don't know. Okay, there are something wrong, but no problem. I don't know why it changed it, but okay. Close. This is not completed model. I will open complete model. So if I open not completed model, like I showed to you, they give me like a message, formation compressibility not specified. So we need to put rock compressibility and give me like a guideline. This is a good, recommend a non-zero value, typical 10 minus 5 psi, something like that. So it support you for your work also. Okay, so it's need to fill red, and this data need to be filled. If I go again, close, and I will open complete model, completed. Okay. Everything right, correct is okay. So now I'd like to show for you the component and good advantage from CMG related to component, especially you are working in EOR and thermal application. So there are a specific issue for define the, your fluid properties. So from here, if I select a component and go to here, it's easy way to create or generate your model by black, or if you don't have if you have a new you don't have a lab experimental and equation of state, so will be used like a correlation. So from here you will add a BVD, and then from here you will generate BVD table using correlation, simple way, and tell him some parameter here related to reservoir temperature, bubble point, if you measured, or will get it from calculated from gas oil ratio, generated from gas oil ratio, densities, something like that. What is the correlation you suggest to build your properties? Simple information what you have, and it's easy to create these properties. I will delete these. Yes, I don't need. And if I go to, sorry. That's it. So from here, like here, this is the data already entered to this software. He defined only temperature and defined oil density and the gas gravity. And oil density, you can select a stock tank oil density, normal units, or like a specific gravity of oil or API. So for this API is 35 API degree. It's easy, yani. And also for gravity of gas, what is the water phase, for motion volume factor. These items defined after only generate water properties by defining temperature and reference pressure and salinity. After that, the software directly defines the properties of water. That's it. It's a simple way to define your BVT if you don't have a complete BVT. If you have complete BVT, also it's easy. You can go here and throw in a BVT table, and once generate, and after finish this, you will click apply. BVT table will be created directly. Another way, if you have a BVD table, it's easy to create it. Okay, create this table, but copy paste. Okay. The other point, you can create a BVT using application of CMG, like I mentioned, WinProp. It's a compositional, it's equation state application to create a model of fuel fluid. And is specialized also for heavy oil and solvent mixture and CO2 mixture. So it's beneficial to use it for the EOR project. Okay, let's go to Builder. So this is the components to enter your component. So here, if you have WinProp generator model, you will create a generator model or launch WinProp from here and start to edit that. The main important or main advantage for CMG, if you go for a component, there are something called process wizard, or from here component process wizard. If I select the process wizard and this model is black oil, so it gives me an option to create issues related to polymer injection. If you create and give me guidelines for this, like the upper viscosity limit for polymer is blah blah blah, and the lower minimum average permeability should be like a guideline to support any engineer to work for this in easy way. And then require some parameter, put a small parameter, polymer half-life, and what is the parameter need to go for your application. So it will facilitate your work, especially in a complex project like EOR. Okay, so this is for IMAX. If I go to select, let me open a new pillar here. Okay, and then open, sorry, select, create a new, but I will create a star using this unit, no problem, and click OK, because I'm interested about component. If I go to component in here or here, like I mentioned, and go process wizard. So from process wizard, there are different applications like add, modify geochemistry, foamy oil, combustion model with optional H2 generation, low saline, alkaline, surfactant, foam polymer, asphaltene precipitation, nanoparticle, geothermal model. If I go to select geothermal model, and this is a new application for any reservoir engineer will be used in the future. So give us some indication to work on it, and give us or choose a geothermal model you need. for example, loop, and that too easy to fill up and facilitate your work. So CMG, it's not only a simulation, but facilitate your work as an engineer working for EOR. Now let's go back for Builder, and then I'd like to show you option also for relative permeability. If I go to select rock fluid, okay, and select here rock type, okay, it's easy to just to generate table using correlation. Just enter the endpoint and put exponential parameter here. He make a suggestion for, exponential, like 1 in fracture or system or something like that. So it's guide you to create just using endpoint and put the exponential here. Easy to create, or paste the table. Also include capillary pressure here in your table, and due to injection, so you need to work in hysteresis modeling, so give you also option related to hysteresis. Okay, sure, you can create different rock type by creating here new rock type and then distribute this rock type on your grid. It's easy to change if you are working in a matching and need to change this curve, moving this curve. So it's easy to move from here. It's a good option. So change the shape of curve. Sure, I know once you change these points, directly change your table. Sure, this point will be affect negative once you make a running, so need smooth. So in a tool, you will give a smooth table and click OK. He will smooth this table. Okay, so it's easy to build your relative probability curve. It's easy to move or change shape of relative probability curve, even change numbers or change the shape of curve. Also, there are issues we can change curve scaling. Here we don't need to change the by curve, but change only the endpoint from here, and then click OK. It's easy to change your relative probability. I will show for you also if you change, if you go for a thermal, because there are options also for thermal. Okay, and create here. And if I go to, like I told you, this is the reservoir, this is the component, and this is a workflow, so it's easy to work and easy to build. Now I will go to rock fluid, and there are like good option to use create a endpoint depend on temperature, because if you inject steam, the endpoint will be changed with temperature. So it will be go from relative probability curve table here, give you your option to change what you have from in a relative probability, even related to table value or related to temperature depends. And in a temperature depends, it will be easy to create a range of temperature and also create like an interpolation sets to give the range. What is the change of SWR in a cold condition and in a hot or steam condition? So it will give you a variety not enter two relative probabilities. It's easy to build, easy to create, and affect also in your history match and sensitivity analysis. It's easy to work on it. I hope this part is okay, because in a thermal you need a temperature effect on a relative probability, because it affect on in reducing a relative probability to oil and sometimes increasing a relative probability to water by using the temperature. Okay, so if I need to show the effect, I will go to here and I will go to diagnostic plot. So like you see here, there are like two curves. One is related to cold condition and the other is related to hot condition and or steam condition. What is the effect on relative probability? So once the reservoir temperature go to higher temperature, use the other curve or interpolated curve between two temperatures. Okay, now let me show for you a good small video about CMG. Then I will create a thermal model. So from this video, the company tell us for using this application, IMAX simulator or GEMS simulator, compositional simulator, or start simulation, even builder, result, all of these applications support all activities related to advanced reservoir engineer, thermal, unconventional, artificial intelligence, machine learning, chemical, EOR, and also geothermal and carbon storage. So we speak about a good application, good software to support any reservoir engineer. Now, I'd like to create with you, pattern for injection for any study. If you go to create a pattern, so I will open builder. Okay, and then from here, I will create a new. Then I will select stars, thermal. I will select SI unit. By the way, advanced, if you need to change something, for example, the unit here. Okay, and the date, I will write 2011. Jan, rest of Jan, okay. Single porosity, of course, I will select also single porosity. Okay. He asked me after I create why, because it's difficult to change these items after build your model. Now I will create my grids. Again, I told to you there are three methods to create a grid. First, create a grid symbol. Second, from wells, well trajectory and well tops, and make a using geostatistical issue, open a map, and then go to create a geostatistical. The last one is, I will show for you before I start. So the last one, if I go here and create open, whatever I have, okay, is RISCO file. RISCO file is extracted from other static modular. So from here, I can go to here, the risk, open risk file, or from here, I can go import from another risk file. Then if I go to production, wire data, intro, I put here, open, simple way, okay. And he will ask me, this is the data in risk file, null block, permeability, porosity, and this is the parameter in CMG. So if I delete this one, مثلا, and go to select the porosity here, and from CMG porosity, and add selection to map, simple, okay. So I load the risk file 3D, okay, and then from tools, I can go to create statistics, porosity here. So minimum average porosity is 16% average porosity. Okay, so this is the third method. Now we will create a simple one. Let's go here in builder, and we create a thermal CMG stars. Then we will go to create a grids and create a quick pattern. Then we will select normal 5 pattern area is called it will be called 10 acres, and reservoir thickness it will be 500 meter. Sorry, 500 meter. Top reservoir here it will be reservoir thickness, sorry, 30 meter. Top reservoir at 500 meter. This simple matter. And approximately block, a deep angle is 0. Approximately block thickness will be 4 meter. Approximately block size in X and Y will be 6 meter. And then we will be make a calculation. He will calculate X and Y. This is the shape of my pattern. It's normal. So 4 injector and 1 producer. If I click OK, he creates the model. And if I go to select 3D model view, this is a view of model. If I need more transparency, so from here, properties, and then grid. Sorry, 1 minute. Let's go maps, 3D setting, and then I can transparency. Okay, it will be like transparency to be see the shape of wells and the shape of wells inside the reservoir. Okay, after that, I'd like to specify the property like porosity and permeability. So I go to specify porosity, permeability and porosity. So I will click porosity 0.30%. Permeability will be 400. And here also 400 meter. I can write 400 or I can make a equal, okay. And then in K, it will be 40, or I can make multiply by 0.10. Then click OK. Then OK. Still, I have an issue because I have issue. Okay. No, I don't have any issue here, but I will go to define some thermal rock types. Here is the thermal, so it will be not defined only the permeability and the porosity, but also another parameter. So in a rock compressibility, so I will create first new rock cell. Okay, and in porosity reference pressure, I will tell you 8,500. Okay, and formation compressibility 1.8 E minus 5. Okay, and then I can enter also some parameters related to thermal properties. I can just apply thermal properties. Volumetric heat capacity 2.35. This is from literature review, E power 6. And also I can put thermal conductivity phase mixing, put complex. Yeah, just a parameter. Every case you can study, but this is just a parameter for tutorial, just to test the idea. Okay, thermal conductivity of reservoir, thermal conductivity of water, 5.3 or 4. Oil phase, it will be 8,000, around 8,000. For gas phase, it's around 2,000. Okay, apply. Okay, you can also overburden and underburden. Okay, here you will complete all things related to thermal parameter like that. Then click OK. We can save it, file, save as, and then we can click here to search for the location. Okay, and I can save it like test. Save. Okay. Okay. Then I will create a BVD. So I will go to component, click on properties, launch, sorry, import black oil BVD, because I don't have complete equation of state or something. So I just have a simple parameter from my fluid. Launch BVD, please select, select the unit first. So it's like a SI unit. Then I will generate. After that, I will tools. I go to tools. So I create one here. I have one. I create a tool and generate BVD table using correlation. I specify reservoir temperature at 37.7778. Also, we can generate maximum pressure for table is 12,000 kilopascal, and bubble point, assuming it's 8,576, and density, we can select API 21, and the gas density, it will be gas gravity 0.65. Okay, then I will set and update values of reservoir temperature, fluid densities. Then I can create apply. It told me, do you wish to include calculated value oil compressibility? Okay. I can, now I will tell no, I will select to be like a constant value. Then I can go directly to BVD table. Okay, and I will found the BVD already created. But there are different check. First, the bubble point. Remember, the bubble point is 8,576. The RS is 30 0.9 meter cube per meter cube, which is normal for this type of reservoir. But viscosity for this type of reservoir is very low. So it's need to adjust this viscosity. Okay, so from tools, we create shift column value to match. Sorry, we'll select viscosity of oil, and from tools, shift column value to match, and then at a pressure, we'll put the bubble point pressure 8576 kilopascal, and put from my data, it's called 120 and click OK. You will find the viscosity is modified. This is because we use correlation. So correlation, sometimes some changes from what we need. Okay. Then from here, we'll insert, we need to, in a general tab, we'll enter oil compressibility, because like we mentioned, we need a fixed value. So it will be 1 e power 5 minus 5. Okay. Okay. And we need to create like a water property. So we write 37. The reference pressure will enter the same bubble point pressure 6, and the salinity will be 10,000. Okay. Okay, and if you go down, you will find the formation water volume factor for water, and the water compressibility will apply. Okay. After that, you will click apply. Okay. Okay. You need to set bubble point again to define bubble point. So I will go to here and set a value, select, and it in, and next. BVD table launch, click launch. The data for gas density or gas gravity has not entered or too small. Maybe there are problems. So I will go to here. Gas density, yes, removed. So it will be 0.65. So it guides you to modify if there are a problem. Okay, again, we will set the bubble point 85. Next. For water properties, okay, I remember this problem. Launch, okay, general. I don't know what's happened, but anyway, 8756. Okay. So created, okay. Created, okay. Apply. Come here. Okay. Okay. Okay, points. It's okay, it's me. Set update value. Forget this. Apply. Okay. Then apply. Okay. Set a value. Next. Okay. So he give us a number of component: oil, one, gas, thermal expansion. That if I need to change this now, I will not change. Okay. Then for heavy oil and gas key value, if I need also to change, but now I will not change. Then for heavy oil, we need viscosity measure. So we'll put temperature versus viscosity, and also whatever you have in a pressure. If you measure this viscosity in a lab at a standard condition, it's okay. If you measure at a higher temperature, like reservoir temperature, we'll write it. Here I write a temperature, then I will write. So it facilitates, even you don't have a full equation of state model, it's easy to build your BVT. Okay. So try to match with correlation. Okay, then build done. Done, finish. So now you have like a model of a BVT component. For time, because the time is need to finish, but this is one of the main workflow to build thermal model. I will go directly to next stage, but after build relative permeability, just to show you what is the next. So I will open, but I will open. Okay. So this is the same parameters, the same component, like I mentioned, the same grid, like I mentioned. If I go to create 3D, it's four spot, like we have 4 injector and 1 producer. And now for a rock fluid, you remember what I presented for you. If I go to here and diagnostic plot, there are 2 curves, one at a lower temperature and one at a high temperature. So we define this. Then we define initial condition. It will be select what is the vertical equilibrium calculation, depth, average, capillary, gravity method, or don't perform vertical equilibrium calculation or block saturation. Because this is simple, we'll use depth, average, capillary pressure calculations, and we set reference pressure and location of reference pressure, the depth, and the contacts, oil water contacts and gas water contacts. This is the initial. In the course, we will go step by step to discuss the initial condition. But now, just this is a simple way. You must to fill, by the way, feedback form by the end of this meeting. Then click apply. So we build the model or pattern from here, weak pattern. Then we create component, and we show for you how to build using a correlation, simple correlation, and the relationship, and prepare also viscosity model because it's a thermal using simple way. And here as a rock fluid rock fluid relative permeability, which depend on temperature, initial condition. Finally, numerical, there are some change control related numerical to facilitate your work. I will show for you, but in the course there are more details, like first time step size after will change. This is the time to start to calculate, and other issue will support calculation to accelerate the performance of model, especially in a thermal case. It's recommended from the company itself. So give us a manual and give us, if you run thermal, use these parameters. Geochemical mechanics, sorry, is optional, so we don't go for that. And for a wells, we need to define the well. So we'll go to wells here and define the parameter for wells. Before we build, just I'd like to show for you something. If I go to create from here, okay, new star SI, whatever, okay. Okay, and then if I go to create reservoir, create a grid, quick better, 5, 10, 30, 500. Here is 4, I don't remember, 4, 6, 8. Okay. If I go to well, if it's 3D. So this is the 5 wells. If I go to wells, there are red bullets. If I go to here, there are only well, injector, and injected fluid. But he recommend injected fluid is water, but not it's water, not steam. So we should define the steam parameter, like a temperature and the steam quality, and the pressure if you have information about the pressure, and also constraints. And here, let me put steam temperature is 325. Steam quality, it's easy to build. Steam quality is around 65. Sorry, you should do you want to apply the change? Yes. And if you constrain, you will operate maximum bottom hole pressure. We put 12,000. Okay. And click apply. So we have like this. We need to transfer all of these action for wells. So we'll select injection by press control and select the event and copy event using the filter and select the other injector here or here from here. Select, and then in a date, which date you need to add this. I select this date and then create a new date for selected well if they don't exist, and then search and add. Okay, and then click OK. So the same constraint like this. Injection fluid is water. Here is a lot of issues, but we select water because the steam and the pressure is 325. I don't know why steam quality changed, but I think it would be 65%. Or let me check how to enter. So, yes, it's 0.65%. Okay, apply. And the steam quality, and same. So steam quality here, 0.65. Steam quality here, yes, 0.65. Yes. Okay, and yes, approve for this. And for producer, you will select operate. Minimum bottom hole pressure will put, for example, let me check. Minimum bottom hole pressure, it will be 200 kilopascal. And I can add another constraint, operate surface liquid rate maximum, because the facilities is here is 100. And I tell to simulation, if you find these constraints, please continue or continue repeat. I will select continue repeat. The maximum number to continue repeat is 1, which means we repeat the calculation for one trial and then we'll stop the we'll stop. If continue, if I will select continue, for example, it's not for this issue. Okay. So this is constraints. I define the injector by steam, by type of fluid, and the constraint. And also for producer, I define the maximum rate For injector, we can also define constraint like operate and maximum surface injection rate. Let me surface water rate and told maximum because the boiler maximum is 250 meter cube per day per each well. Is related to wellhead constraint, and then click apply. Some wells selected in the above difference. Well, do you want to range? Yes. This is, and I don't know. This is the producer. Sorry. So go to operate surface total rate maximum 250 meter cube per day, and then apply. Then take constraint, copy event, select the other injector, dates, create a dates, no, search and add, okay. If I go to here, I already copy the same constraint for all injectors. Okay, so I will go to the case. Go to the case. Now all of things is right, so it's okay. Simple build model and the well constraints well condition is defined, so it's easy to initiate the model. So to initiate the model, before initiate the model, you should select what is the output report. From out report, you got simulation result output, and tell the simulation what data need, which data need to be output and the frequency. So go select, and from here, for example, we select net cumulative energy and net heater rate. Of course, we need pressure. Relative permeability. Let's go pressure. مثلا. So we select the pressure and also select the grid for a grid or for well and something like that. And the specified frequency here, every time and date and something like that. So we build the model reservoir. We enter component. We enter rock and the fluid and define temperature dependence, initial condition, define numerical suggested by the company, so it will be easy to fill. And then well, we put the constraint for injection and the producer, and then in and out, output control. Then we will run the model by right here. He told us, do you need to save? Okay, I will go file. I will click save as and search for a model. In this case, I will tell test2, save. Okay. And then in start, do you wish to save data before? Yes. So he asked me, do you want to validate the data to be run in CMG stars for a thermal? We can select run and wait. There is no error, no problem, and no errors message, so it's okay. We can run initialization just to know the original hydrocarbon in place. So run this initialization, and there are table below tell us what is the oil phase volume, what is the solid phase volume, what is the gases volume, initial, of course, something like that. And then we can go. This is just to test. We can run from here, by the way, directly, run normal, but I'd like to prefer to go outside, and I will. Okay. Let me go. Sorry. And I will show for you. We'll go to location of location of your data. I save it here. Let me check the location file. Yes. Thermal EOR. Okay. So here I will go to thermal EOR course solution test 2. Sorry. What is this? I don't know. Sorry. Test 2. Test 2. Then I will drag it to simulation version and then click OK. I'd like to show for you the log. So from if I go here down, there are like day 1, test 2, normal and running. We'll go to launcher again. It's green. If I need to see the log, I will be finished خلاص. What 1 minute. Running and start to count, run the data 1% and 2%. It will take 4 minutes, but I will leave it at down. Then after run the data, it's easy to go for example, exercise 1 here. This is the other case, and go to result. To show the result. Okay, so this is the other case, running case. And if I go to select, for example, oil rate and select well producer, this is the oil rate. And I can show injection rate also. So I can add time series, well exercise, injector 1. And from here, I can put, for example, water, injection rate, water rate, standard condition, add a new plot. So it's like not reach to maximum limit. Just this is the water rate, and if I injection pressure, bottom hole pressure. So it's, this is a constraint of bottom hole pressure. So it's easy to plot this result, and also easy to see 3D. Okay. And from display here, it's easy to select, for example, temperature, and you can rotate your model and click run. So it's easy stop. It's easy at this time to follow the temperature with time and something like that. There are different options related to result. I think due to time, I cannot present it, but during the course, interesting course, I can show different cases and step by step to build your thermal model and make analysis for your thermal model. Thank you for your listening to this webinar. And if you have any question, I will be very happy to ask your question now.
Thank you, Mr. George, for your rich webinar. This is actually like 2 hours webinar. We usually have 1 hour. So thank you so much for sharing this too much information with us. And more information to be shared with participants of the course. So I really encourage the audience to join us in the upcoming course on the 19th of August. One last note is that I have sent the feedback form link in the chat area, so please take a minute to share your thoughts with us. This helps us to improve in the next webinars and to improve our services as well. I will share again the link in the chat, just 1 minute. And in the meanwhile, if you have any question, please share your questions with us. We really don't have too much time for questions, but we can take like 1 or 2 questions if we have.
I see the language not English, so please, please tell us in English.
Carlos. Yeah,
Carlos.
Carlos, I think you are typing in Spanish. Please, can you type in English?
Sira, possible.
Yeah, it's difficult. We know we all.
I understood English.
Yeah, not English.
Okay, somebody tell. Thank you for your feedback. It's okay. Will be possible have this topic. Will be possible have this topic.
I think he is asking about sharing the documents and something like this.
The documents, there is no documents, like you see, it's all video. So the video, I think, recorded.
Yeah, it's now live streaming on YouTube. So whenever any one of us would like to revisit this webinar, it will be like lifetime access. So you have the time to revisit the webinar whenever you want.
When will be official course date? 19 of August. 19 of August here. It will be 19 not next, after 2 weeks. 19 of August, 19, 20, 21, I think, and 22 is vacation. Then 23, 24.
Yes.
5 days. 22 is vacation.
Yeah, we just received a question from John. John is asking, how can we combine the result we got in CMG with machine learning? Any idea with this?
Look, for CMG, quickly, for CMG, there are like a tool here. Okay, like a tool is called CMOST AI, artificial intelligence. But it's used artificial intelligence for build history match algorithm to support quickly history match and optimization. I think there are also easy to write Python code now for CMG to develop the software. So at this point, it's easy to make a migration for artificial intelligence and CMG. Okay. Even the next course, I will not discuss the artificial intelligence. So maybe other courses. If the next course will be okay, we promise the OBA to continue with other interesting topic for CMG. So in future, maybe.
Yeah, this is gonna be really a good chance for us.
Yes.
Yeah.
I see somebody from Cameroon. My first time of getting a composition for a software simulation. I didn't quite understand, Pete. I'm glad to have a participate. Maybe because the time is limited, I believe if you attend the course 5 days, step by step, it will be easy to get all information and all material. Again, CMG, it's organized workflow and friendly. Tell you stop, this is wrong, please correct. So easy to build and easy to create your model and create your workflow to finish your FDP quickly for task. And Carlos asked, and it will be possible to have the video record to see again before the official course. I saw record for this webinar.
Yes, I just mentioned that as it's live streaming on YouTube, it will remain on YouTube. So if you like to get the recording, it will be available on YouTube, on our YouTube channel.
Yeah,
Just type.
available.
Yeah, it's available. Just after once we finish the webinar, it will be available as a recording on YouTube. So you just have to go to YouTube and type OBA courses or OBA energy. You'll find our YouTube channel and check the videos, and the latest one would be the CMG session.
Somebody asked about able to supply the software, something like that. For me, I'm using license for me, but I see 2015 available. You can download and try. I don't know. 2015 is different between 2015 and the recent version. New function, of course, but the same basics, so it can be easy used for a thermal, for example. And result application. Result, it's start 2016. So you will not find the same result plan, but you can build the model using CMG. So I don't know. You can use 2015 or search for the other, the updated one. In CMG, data can be used with Schlumberger software. Yes, if you have a build your static model using Betrel, it's easy to load Risco file and start your dynamic model. If you have black oil model, a black oil data file using E100, Eclipse 100, you can easy to convert to CMG. It's easy, yeah. Simple workflow. For a thermal Schlumberger data file, unfortunately needs some work to convert, but it's easy also. If I go to here, file, I will show convert simulator type. If it's other type, it's easy to convert to CMG product. Yeah. Okay, thanks. I understood, Carlos. Thank you, Carlos. The software, could it expect BVT data from BVTI? The issue we can get like the parameter of matching and using once you build your BVT in WinProb. Believe me, WinProb is the highest software for BVT if you work in heavy oil on EOR. There are different application, combination application, especially if you speak about absorption, if you speak about combination between solvent and oil. So I encourage you, if you will work in heavy oil or EOR, I prefer for you to use WinProb. If we'll go to CMG, please, will the training data set be provided? In a training, we will manage, not be a big issue. We'll manage to provide the data set. Okay, thank you. Again, feedback, and the courses, live courses. And if you need to enroll, I saw if you need to tell something by the end.
Yeah, you have your space. It's okay. I just want to say thanks again, Mr. George, for giving this 2-hour webinar. This is a very long time, actually. And also thanks for our audience joining us till the end. We have like 50 participants joining us today, staying from the beginning of the webinar till the end. So thank you so much for your passion to learn and for staying with us. Stay tuned for next updates on our social media platforms for amazing and interesting series of webinars in the upcoming period. Have a good night. Thanks all. Thanks, Mr. George. See you soon.
See you soon. And for a data and the material, something within the course, we will manage the requirements. Thank you very much. Thank you. Bye-bye.
Bye.
Bye.